sequences. So we're going to recognize and extend geometric sequences. And then we're going to do finding the nth term of a geometric sequence. So this is pretty straightforward today then. So basically we're looking at stuff where when we talk about a geometric sequence, we're talking about something that is, when it changes from one number to the next, it's always by multiplication. Now, sometimes when it's getting bigger, that means that we're multiplying by a number greater than 1. And if the numbers are getting smaller, then we're multiplying by a number between 0 and 1. But when you're talking about geometric sequences, it's always multiplication. We never do division. Even though we might be cutting things in half, we have to think of that as multiplying by 1/2, not dividing by 2. So when you're talking about something happening geometrically, we're always talking about it. We are multiplying by the same number each time to get to a new number. So here shows a table from somebody bungee jumping, that when they first bounced, they went up 200 feet, and then second bounce 80 feet, and then 32 feet, and then keeps getting smaller and smaller until eventually they stop bouncing at all. Right? And so this is what's called a geometric sequence. And the ratio of successive terms is the same number r, which we call the common ratio. So the number that we multiply by each time to get from one term to the next is called the common ratio, and we use the letter r to represent that common ratio. So first we're just going to look at a couple of examples where they're going to give us some terms in a sequence that we need to find the next 3 terms. Well, the first thing you have to do is you have to find the value of r. And so to find the value of r, what we do is we will divide each term by the one before it. Okay? So to find the common ratio r, we're going to divide each term by the one before it. So here we can see that with our terms 1, 4, 16, and 64, we'll take 4 divided by 1, 16 divided by 4, and 64 divided by 16. And those will give us the common ratio. Now, if they tell us it is a geometric sequence, we really only need to do it once to find out what the value of r is, because if it is a geometric sequence, we know it's always being multiplied by the same amount, so we only need to do it one time. So with our good division skills, we know that each one of these is 4. And if you ever end up in a situation where they give you that 1 is one of your terms, that makes it really easy, because you just take the one next to it and divide by 1, and that, so whatever the one next to the 1 is, that's always going to be your common ratio. So here our common ratio is 4. So to find the next 3 terms, we're just going to multiply 64 by 4, and then multiply by 4 again, and multiply by 4 again. Now the one thing is to remember that your calculator gives you, makes this really easy, and remind you of that procedure that makes it the easiest once it comes up. So here my 4th term is 64, the last one I know. So what I'll do with my calculator then is, to make it easiest for me, is I will put in 64 and hit enter. So what that's just done is it's stored 64 into the last answer of my calculator, and then I can just press times 4. All right, so there's my next number is 256, and then instead of having to say times 4 all the time, all I have to do then is just hit enter 2 more times. Okay? So instead of having to keep typing in times 4 and times 4, all you got to do is hit enter, and it'll do it for you. Right? So our next 3 terms are 256, 1024, and 4096. So. All right, and there's our next three terms. All right, let's look at another one. Uh-oh. I have a little problem here. So my little hand there is in front of the negative. There should be a negative sign there. Come on. Should be -9. There we go. -9, 3, -1, 1/3, and -1/9. So we want to find the next three terms. So we'll find the value of r by dividing each term by the one before. So since we know this is a geometric sequence, all we need to do is pick two numbers that are in the sequence and divide them. So you can do any two you want. Lots of times it's going to be the first two that you'll end up doing. Here we have -1, so I like that one best. So here I've got 1/3 divided by -1. Well, we know anything divided by 1 is just that number. So 1/3 divided by -1 is going to be -1/3. So in this case, r is equal to -1/3. Now the thing is, you just need to make sure that in this case that you're always getting fractions for your answer. And with the numerator being 1, that actually makes it easy because all we really need to do is focus on the denominator then. So we've got -1/9 times -1/3. All right, to get the next term, so 9 times 3 is 27, so it's going to be a positive 1/27. And so really all I need to do, if I'm using my calculator for this, instead of doing the fraction, just use the denominators. All right, I know there'll be a 1 in the numerator, and the sign is changing every time. All right, so you should always end up with positive, negative, positive, negative. So 1/27 times -1/3, -1/81, and -1/81 times -1/3, positive 1/243. Right. So the one big thing with fractions, a lot of times all you need to do is worry about just multiplying them correctly. So geometric sequences can be thought of as functions. The term number or position in the sequence is the input of the function, and the term itself is the output of the function. So here we have a sequence that's 3, 6, 12, 24, and so the positions of them are 1, 2, 3, and 4. And if you notice here, we're using what's called subscript variables here. So we're going to call the first term is a sub 1. The second term would be a sub 2, then a sub 3, then a sub 4, and then so on. To find the output of a sub n of a geometric sequence, when n is a large number, you need an equation or a function rule. So if we look for a pattern to find a function rule for the sequence above. So here we have a pattern for that. So the first term is 3. We call that a sub 1. The first term is 3 times 2 to the first power. So we would say that would be a sub 1 times r to the first power, because we multiplied by r once. Then the third term, we would multiply by r 2 times. So we multiply by 2 twice, or r squared. Fourth term, multiplying by r cubed. And the nth term, then, we multiply by n minus 1. All right, so whatever term number we want, minus 1. Because we always, with the first term, we don't multiply that one by r, but we multiply by r to get to the following terms. So that leads to what's called the general rule for a geometric sequence, which is a sub n, which gives me the nth term, is equal to a sub 1, the first term, times r raised to the power of n minus 1. And that reminds me that I'll need to give you note cards for chapter 11 then. That'll be the first thing we put on the note card, be that rule.
Thank you.
All right, so a sub n gives us the last term that we're trying to find. A sub 1 is the first term of the sequence. R is the common ratio. And then we're going to raise it to the power of n minus 1. So here it says the first term of a geometric sequence is 500. Common ratio is 0.2. What is the seventh term of the sequence? So when I do this, I like to write down what each thing represents. That way all I need to do is plug them in, but noticing what they are first. So I need three things. I need n, I need a sub 1, and I need r. Need those three things to be able to find the nth term of the sequence. All right, so here they tell me the first term of the sequence is 500. So there's my a sub 1. The common ratio is 0.2. So there's r. And they want us to find the seventh term. So there's n. So then all I have to do is just plug those numbers into the formula to find the seventh term. So a sub 7 equals 500 times 0.2 to the power of 7 minus 1. Now one thing, make sure I would always put r in parentheses just to help you, because if r ever ends up being a negative number, that way you'll guarantee that you have a negative inside the parentheses. And then we can just go to the home screen of our calculator and type that in to find out what it would equal. So 500 times, and I'm going to put this in parentheses just to make sure, 0.2 to the power of 6. So we get 0.032. So a sub 7 equals 0.032. So the seventh term of the sequence is that little number. All right, it's decreasing really fast. Now I could also do this. If I can't remember how to write that formula, then I could just type in 500, right, times 0.2. So there's my first term. Here's my second term. Third, fourth, fifth, and there's the sixth one. Oops. And there's the seventh one. There we go, the one we're looking for. So you can use that, what we call this, the last answer feature of the calculator to do it also. If you can't remember the formula, you can just type it in like that. All right. So get another one. Geometric sequence, a sub 1 equals 5, r equals 2. Find the sixth term of the sequence. All right, why don't you go ahead and just find that one. All right, so plug in 5 for a sub 1, 2 for r, n equals 6, and we get 160 for that one. All right, let's look at another example. All right. So what is the ninth term of the geometric sequence when all they do is give us the sequence itself? So remember, we're still looking at, we've got a sub n equals a sub 1 times r to the n minus 1. Right? Right. So we still need to find each of those numbers. Well, here they tell us what n is. That's the ninth term. So n is 9. A sub 1, the first one, is 2. And then we just have to calculate r in this case. So we'll take negative 6, divide by 2, and get negative 3. All right, so the ninth term, a sub 9 equals the first term times r raised to the power of 9 minus 1. Now it's important that you use parentheses, because if you don't use parentheses in this case, when you plug it in, you're going to end up with a negative number when it should be a positive number. Okay? If you don't use the parentheses on your calculator, it's going to give you the wrong answer. So let's look at the two different ways of doing this then. So, all right, 2 times negative 3 to the power of 8. All right, so there's our number. All right, and the reason you got to use parentheses, because if I just say 2 times negative 3 to the power of 8, then it's going to give me a negative 13,122. And this is definitely going to be a positive number. Now, how do I know that for sure, though? Right? So it goes positive, negative, positive, negative. The odd numbered terms are going to be positive, and the even numbered terms are going to be negative. Okay, so the first term and the third term are positive. Second and fourth are negative. So if I'm looking for the ninth term, I got to make sure that when I get that number, it's got to be a positive number, because all the odd numbered ones are positive. Okay. All right, so be careful with that. All right, so let's do this number 2 here then. Okay. And down here is just a reminder with your negatives. Okay. All right, so let's do a couple of word problems that involve geometric sequences. So the balls drop from a tower. The table shows the heights of the balls' bounces, which form a geometric sequence. What is the height of the ball after the 6th bounce? All right, so we can use the formula for doing it, or you can just find this answer by using your calculator. All right, which method you use is up to you. But once again, here we have a sub 1 is 300. R is going to be, let's see, 150 over 300, which I know that's 1/2. And n is 6. All right, so whichever method you use to do it, whether you just want to take your calculator and say, okay, here's the third bounce is 75. So then if I go 75 times 0.5, there's the fourth bounce, times 0.5, there's my fifth bounce, and there's my sixth bounce. Okay, so just remember that we need to write out our answer. Okay, so the height So sixth is, what do we get? 9.75, and make sure you have your units, 9.375 centimeters. All right, so you can do it right from the calculator, or if you want to use the formula, you can use the formula to do it also. So 300 times 0.5, oops, didn't use parentheses, raised to the fifth power. Okay. All right. Table shows a car's value for 3 years after it's purchased. The values form a geometric sequence. How much will the car be worth after 8 years? All right, so let's use our formula here. So let's see, n is 8, a sub 1 is 18,000, and r is 15,300 over 18,000. We get 0.85. So a sub 8, 18,000 times 0.85 to the power of 8 minus 1. So the car is worth $5,570.39 after 8 years. Depreciation of automobiles. After a while, they don't. It's less and less. But all right. So you buy a car, buy a brand new car, drive it off the lot, and it's now worth only 80% of what it was 5 minutes before that. It's basically what they do. Okay. All right, geometric sequences. All right, so just make sure then you write a sentence that the value of the car after 8 years would be $5,570.39.